Okay, in this video, we are going to be graphing quadratics in intercept form. So as a quick review, standard form of a quadratic is y equals ax squared plus bx plus c. Vertex form is y equals a, and then in parentheses, x minus h squared plus k. Keep in mind that your vertex is hk. Versus on standard form, to find your vertex when it's in that form, you have to do negative b over 2a to find the x value, and then you'll plug that back in to find the y value. So today we're learning intercept form. So intercept form is y equals a, x minus p times x minus q. And p and q are x-intercepts. Oh, sorry. Okay, so now we're going to look at this prerequisite skills practice. So it says to factor the polynomial. We've been doing a lot of factoring because it's going to be very useful for the future chapters, future classes, current chapter. It's just a skill that we need to have mastered. So this is a trinomial. I look and I see if any GCFs can come out. There's no GCF, so now I'm not ready to do what multiplies to AC, which is 2 times negative 4, that's negative 8, and adds to B, which is 3. So we think about things that multiply to negative 8. So I'm going to make my list here. And none of those add to 3. So when that happens, it is just not factorable. Which we haven't seen a whole lot, but it completely happens. It's definitely okay. And we just want to make a note being like, okay, that's not factorable, and that's how it looks. Okay. So our new format is intercept form. So we talked about the intercepts are P and Q. Okay, so when you need to find the axis of symmetry for the vertex, you are going to take your P, your intercept, which is P, plus the intercept, which is Q, and divide by 2. The reason that is because the P and the Q, the intercepts, are symmetric. So the vertex is halfway between them, or the axis of symmetry is halfway between them. And so when you add them and divide it by 2, you're finding the halfway point. So then once you have your vertex, you'll be able to plug it back in and find the y value of the vertex, or you'll be able to write your axis of symmetry as x equals the x value of the vertex. And then as with the other ones, a, number in front of the x minus p and x minus q, if it's positive, it opens up. If it's negative, it opens down. Okay, so let's look at this. So we have x plus 1. So if you set it equal to 0, you find negative 1. And x minus 5, if you set it equal to 0, you get 5. So the x-intercepts are negative 1 and 5. Okay, so if you want to go ahead and put that on your graph, you can. I did not label your graph paper here because some of our numbers today may be bigger than 10. So we're just going to go ahead and make a note that we're going by ones. I think the y-axis will also go by ones. If we find out, we can always change it. So there's my x-intercepts. So to find my vertex, you take your x-intercepts and you add them and divide by 2. So negative 1 plus 5 is 4. Divided by 2 is 2. So your vertex is 2. And then you literally just plug it back in, and you can totally use a calculator on this part. And so you're going to plug that back into a calculator just as it is right there. You can also do it by hand, either way. So I got 9. So the vertex is 2, 9. So the axis of symmetry is x equals 2. So it must have x equals on there. So 2, 9 is up here. And then I'm going to just draw my axis of symmetry in real light right here. And we have 2 points now. We need one more set of points. So when you think about your table, you have your vertex at 2, 9. So maybe finding one at 3 or 4. We know at 5 it's 0. So let's plug in 3 into the equation. Let's see what we get. So I get 8. So over 3 up 8, find a symmetrical point, and that's good enough. You have the vertex plus 2 points on each side. Okay, so this works the exact same way. So your x-intercepts, you have x minus 1 equals 0, that gets you 1. And you have x plus 3 equals 0, that gets you negative 3. So there's your x-intercepts. I'm going to go ahead and find the vertex before I graph it to see how big my scale needs to be. So when I find my vertex, if you know the intercepts, you add them and divide by 2. So you get negative 2 divided by 2 is negative 1. And then you're going to go back into the equation and plug in negative 1. And you're going to type that into your calculator or do it by hand. And I got negative 8. So I would say that I can go ahead and still go by ones here. I don't think I have to change that. So like this can go by ones and this can go by ones. You do want to label your x and y axis so you know. So I have negative 1 down to negative 8 right there. And then my intercepts were at 1 and at negative 3. I'm going to go ahead and draw in my axis of symmetry. All right, and so I need one more point. So when you think about your point, you have negative 1, negative 8. Let's find another one to the right. Let's do 0. So if I plug in 0, I get negative 6. And then reflect that point over the axis of symmetry. And there's your graph. And then your axis of symmetry, I forgot to write it down, is x equals negative 1.